Okay, so the next thing we're going to talk about is when we rewrite a rational expression in simplest form. So we've really almost already done this when we were looking at functions or operations between functions. When we divided two functions, if you think about what we did, we first wrote them in the division form. We factored the numerator and the denominator. We canceled anything, and we stated the domain. We'll look at what we're going to do to put a rational expression in simplest form. We're going to first factor the numerator and denominator. Then we will cancel any common factors that appear with multiplication because I cannot cancel with add or subtract. Then I'll state the domain. And look at how I'm going to state the domain. I'm going to state the domain by determining what values make the denominator 0. And once again, I'm going to make sure to look at the denominator before things were canceled out. Another way that it can be thought of is without it in the flow map is 1 factor, 2 list domain, 3 cancel any like terms. Okay? So if you would rather list the domain before you cancel so you don't forget to look at the denominator before it was canceled, that's another way you can think of it. So either the flow map up there or this list of 1, 2, 3 down here. I have 3 examples to look at. Please do make sure and watch all the way through the third because the third one is slightly different than the first 2. So if I look at this, rewrite in simplest form, first thing I'm going to do is factor. I know that x squared plus 10x plus 25. I'm going to do a factor sum table since I start with an x squared, and I'll do factors of 25 with a sum of 10. Well, I know that's 5 times 5 and 5 plus 5. So my top will factor to be x plus 5 and x plus 5. My denominator, well, now I want factors of 20 with a sum of 9. Oops, I don't know why that moved. All right, I guess I'm going to have to just deal with this like this. Sorry about that. So let me at least switch pen colors here for you. So I want factors of 20 now with a sum of 9, and I already have because it's hard to read x plus 5 times x plus 5 on top. So then my factors of 20 with a sum of 9, I can go ahead and say 5 times 4 is 20, and 5 plus 4 is 9, giving me x plus 5 and x plus 4. So I know if I want to now, if I can either cancel it or I can look at the domain. My domain, if I set each of these pieces equal to 0, if I set x plus 5 equals 0 and x plus 4 equals 0, I see x equals -5 and x equals -4. I also see I can cancel one of my x plus 5 factors. So that leaves me with a final answer then of x plus 5 over x plus 4 with the domain of x not equaling -5 and x not equaling -4. So again, very similar to some stuff we've already looked at. So let's now look at the second example. Doing the same for the second example, remember we have learned multiple ways to factor. So right away I see on top I have a GCF of 3, so I'm going to take that 3 out and I'm left with 2 minus x. On the bottom, I see I can do factor sum tables again, so I'm going to do factors of 8 with a sum of -6. Well, I know that -2 times -4 is +8, and -2 plus -4 is -6. So I'm going to say the bottom factors to be x minus 2 and x minus 4. So I noticed that, well, first of all, if I set each of these pieces equal to 0, x minus 2 equals 0, x minus 4 equals 0, I get x equals 2 and x equals 4. But I also notice here that 2 minus x and x minus 2 are very similar. However, they are not the same. I cannot cancel them. The reason is because I have a positive 2 up here. Sign belongs to the number, so I have a -2 down here. I have a negative x up here and a positive x down here. So they're not the same, but it sounds like they are opposites. Well, if I have opposites, what I can do is I can factor a -1 out of one of them. I'm going to go ahead and factor a -1 out of the top. So when I factor a -1 out, I get -3. My 2 becomes -2. My negative x becomes plus x. And now I have a common factor on top and bottom that I can cancel out because now these are the same because they both have a positive x and a -2. Remember, it doesn't matter what order we add in. Giving me a final answer of -3 over x minus 4. I've already determined that x cannot equal 2 and x cannot equal 4, and that is my final answer in simplest form with my restricted domain. Looking at the last example. Okay, so in the previous example, I was dealing with polynomials on both top and bottom. In the first one, I had a trinomial on top and a trinomial on bottom. In the second one, I had a binomial on top and a trinomial on bottom. I had to go through some different factoring methods before I could cancel. Notice here in example 3, I have a monomial on top and a monomial on bottom. There is no separation from adding or subtracting. So since it's a monomial and it's all multiplication, if it's all multiplication, I don't have to factor. My only reason for factoring is to get a multiplication problem so that I can cancel. Well, since I already have multiplication, I'm just going to go ahead and start canceling. I know negative 27 and negative 9 can both be divided by 9, giving me a negative 3 on top and a 1 on the bottom. I know x cubed and x to the fourth can both be divided by x times x times x, or x cubed. So they all cancel on top, and I'm left with just an x on the bottom. Both my y's cancel. So I'm left with the final answer of negative 3 over x. I do still have to state my domain. Well, what would make 9x to the fourth times y equal 0? Well, wouldn't it equal 0 if either x or y were 0? Because if x were 0, 9 times 0 times anything is 0. If y were 0, 9 times anything times 0 is still 0. So I'm going to go ahead and say for my domain that both x cannot be 0 and y cannot be 0. And there's my final answer.